Question 3, part A, asks to show that A lies on this line L1, and we are given the coordinates of A. It is 1, 4, and I have actually plotted that onto our diagram here already, but I will still prove though that it does pass through this point. And you can also notice up here in this blue writing that I've rearranged L1 equation to be in the form y equals mx plus c. I prefer to see equations of straight lines in this form because it's very easy to identify the gradient, which is m, and the y-intercept, which is c. Okay, so if I was to show that point A lies on L1, my rationale here is that if L1 passes through the coordinates 1, 4, so if this line does pass through it, when x equals 1, y will equal 4. So I have I'm going to use this equation down here. It's actually the same equation as my equation given in the exam paper. I've just rearranged it to be in this form, y equals mx plus c. So therefore, y is equal to x on 2 plus 7 on 2. And now I sub in x equals 1 to see if y is going to equal 4. So y is equal to 1 on 2 plus 7 on 2. Now these are fractions. I'll just convert them to decimals so it's clear. 1 on 2 is 0.5 and 7 on 2 is 3.5, and 0.5 plus 3.5 is 4. And that looks good. So when x equals 1, y equals 4. And that proves that this line L1 passes through the coordinate point A. And that is the answer to part A, question 3.